So f of u, if u is g of x, we get f of g of x. As long as the derivatives of derivative of y with respect to u and the derivative of u with respect to x both exist, then we can take the derivative in the fashion written down here. For this, if y equals f of g of x, so we've got basically a function inside of a function, then the derivative of y is going to be the derivative of the outside function, right? Inside part stays the same, times the derivative of the inside function. Right, so derivative of f of g of x times derivative of g of x. And it's kind of written out in words, kind of like I just said them right over here. Derivative of the outside function, the inside stays the same, times the derivative of the inside function. Right, so this is just kind of another representation of it, but this is the one that's kind of more common that I'll refer to most of the time. Now, the way that I kind of explain this to people to help them understand and remember it is it's like a little present. I know you don't think calculus is a present, but have you ever had this happen to you, or someone did this to someone you know? You get a present from somebody, you open the box, and then you see there's another box inside of that box, and you have to open that one, and then you have to open another one. So chain rule is kind of like that, right? We open the outside, or take care of the outside part first. So we do the outside derivative first. We don't change the inside yet. We don't touch it. It stays the same. Then, once that outside is done, then we do the inside part. And today we're just doing things that have like two parts to them, like an outside and inside. We'll do some later next week where you have like an outside, and another one, and another one. Like, so there's like 3 or 4 functions together that you're kind of unwrapping one at a time. All right, but today we'll kind of start off a little bit slower. And we're looking at specific ones that deal with the power rule functions. We talked about power rule before, which is like x to the 5th. This is kind of connected with that. So let's look at the first example together. For number 1, here we have y equals 3x squared minus 5x to the 2nd. So with chain rule, it's when we have a function within a function. So this right here, this 3x squared minus 5x, that's our inside function. Right? It's inside the parentheses. And the outside function would be the squaring part. Right? The outside function is the squared, inside function is the 3x squared minus 5x. So with the chain rule, when we do the derivative, again, it's like unwrapping that present. You take care of the outside part first. Inside is not touched, right? It's untouched until you get the outside done. So outside part is that squared. Think of this like, pretend like this, the 3x squared minus 5x. Think of that as just one big variable. Right? If this was x squared, what's the derivative of x squared? 2x to the first, right? So let's treat it like that. So we were going to have 2 times 3x squared minus 5x to the first power. All right, we don't really need to write that 1, but I'm going to do it for this first one. So this whole thing right here is the derivative of the outside. Right, that's the derivative of the outside. Right, the 1 comes from subtracting from the exponent, just like we would normally. You don't really need the 1, but I threw it in there. All right, times the derivative of the inside. Now we can unwrap the inside present. The 3x squared minus 5x, what's the derivative of that? 6x minus 5. Right, so that's it right there. That's our derivative. And that's 6x minus 5. That's the derivative of the inside.